Hello, the goal of this video is to remind us how to simplify nth roots, which is 7.4 in our textbook. In the middle here, you'll see the notation for nth roots. This n right there is your index. It's called your index. This is going to indicate how many are going to be in a group. This symbol right here, normally you'd say a square root, but in this case here, it's called a radical, because we're going to be changing from square roots to now nth roots. The part under the radical, this B part right there, that also has a name. That is called your radicand. And then the result after you take the nth root is called your root. So what we're going to do here is we're going to look at a couple of examples. We're going to start changing the number on the outside of that radical symbol. Again, that is called your index. And the key thing with that is telling you how many in a group you are looking for. So we're going to treat numbers different than variables. First, let's look at this number. We're going to take 108 and we're going to break it up. It is 54 times 2. 54 is 9 times 6. And we can break each of those down. Normally, when we are looking for square roots, we circle pairs, and any pairs go on the outside of the root, or on the radical. This time, since our index here is 3, we are looking for groups of 3, which means I see 3 threes here we're going to circle. Those 3 threes are going to get put on the outside of the radical. There are one group of 3s. Left behind inside of the radical then should be these 2 2's. Now, if there's more than one thing you're bringing out or leaving in, you're going to take and you're going to multiply those together. So inside the root here, you're going to see the 4, which comes from 2 times 2. To deal with the variables, what we're going to do is we're going to imagine what x to the 6th actually means. It means you have 6 x's that are being multiplied together. As a reminder, our index here is still saying we're looking for groups of 3. So what we're going to do is we're going to circle groups of 3 for our x's. And I can see that there are 2 groups of 3. So on the outside of the radical, we're going to put whatever we are taking out. So we're taking out x's. And your degree here is going to be how many groups you took out. So this is going to be an x squared because I took out an x for my first group and an x for my second group. There were 2 groups in total. There were no x's left behind, so I don't put any inside the root, or the radical symbol rather. So therefore, this would be our final answer to this problem. So let's try the next one. It's the same idea here. Again, this index on the outside means we are looking for groups of 5. So I take 10 and I break it down. It is 5 times 2. Unfortunately, there are no groups of 5 for that. So immediately what I'm going to do is I'm going to have my 5th root here. I'm going to take my 5 and my 2 and I'm going to leave it inside. Again, anything that's inside that's more than one term for numbers, you're going to end up multiplying them. So for your x's, I have 9 x's and I am looking for groups of 5. I'm going to be able to take out one group of x's. Again, if you want to visualize this, you can always end up drawing it out. It ends up taking quite a while though, especially with more than one variable. We have a group of 5 x's here we are bringing out, and I have 4 x's left behind. So inside here is x to the 4th. It's how many are left over. On the outside is how many groups were there. For my y's, I have 2 y's inside, which means I didn't have any groups of 5. There's not enough to make a group. For my z's, I have 21 z's. I'm looking for groups of 5. So all in all, I have 4 groups. You can do this by dividing these numbers if you'd like to. So 21 divided by 5 is going to be 4.2, which means there's 4 whole groups, and then there's some left over. So we have, if we're taking out 4 groups of z's, that means all in all, I have taken out 20 z's. I only have 1 left behind, which means it's going to be z to the 1st power left behind. So this would be our simplified answer for number 2. For number 3, we're going to do the same idea. I'm going to zoom in here so you can see it a little bit more close up. We're going to take 162 and break it down. It is 81 times 2. 81 is 9 times 9, and each of those can be then broken down. I am looking for groups of 4. I see a group of 4 threes, which means the 3 can go on the outside, and the leftover 2 goes on the inside. I have 5 A's. I'm looking for groups of 4, which means I can make one group of A's, and I would have 1 A left over. For my B's, I have 17 B's. I'm looking for groups of 4. So I can see that I'm going to have 4 groups of B's that I can take out. And if I have 4 groups of B's, that means I've used 16 of them and I have 1 left behind. For my C's, I only have 2 C's. I don't have the ability to make any groups of 4. So the C's are going to remain inside my radical symbol. So number 3 would simplify to that. The other part to simplifying nth roots is sometimes you're going to need to use an absolute value symbol in your answer. So in order to answer when we actually use that absolute value, I have some helpful hints over here. You're going to use the absolute value symbol when you have an even index and you have an even degree inside your radicand, but the root, when you take it out, is going to end with an odd degree. We call this even, odd. So visually looking at this, if this number on the outside, this is your index, if this is an even number and the x is raised to an even degree and your answer, so that's kind of the first part is where you check it. If it's an even and an even here, you say, wait a second, I have to check and see if there's absolute values. And the way it's going to be a yes is if when you simplified, you got an odd degree on the outside for your root. If that's the case, then you would use absolute values around that term. And you'd have to check each term individually. So for instance, if it was a y and you had an even exponent for your y, but you got an even answer out, you would not need the absolute values because it doesn't follow the even, odd pattern. So let's see what this looks like with a couple more examples. So for numbers 4 and 5 here, both of them are going to use the absolute value symbol in some format. So if we take and simplify these first, for number 4, we're looking for groups of 4, which means we're going to take out a 3. I have 12 x's and I'm looking for groups of 4, which means I have 3 groups I can take out with nothing left behind. My y's, since I have 8 of them and I'm looking for groups of 4, I have 2 groups in total I can take out with nothing left behind. So I actually don't need my root or my radical anymore because everything got paired up nicely. This would be my answer, but I have to stop and check because I have an even index. I have 2 variables that both started off with even degrees, but only one of them ended up with an odd degree. That is where you're going to use your absolute value symbol. This would be your final answer. So let's take a look at the next one. It's going to be the same premise here. We're going to take and we're going to break everything down. This one we are looking for groups of 6. And so for our numbers, we happen to have exactly one group of 6. So we're going to bring the 2 on the outside. I have 13 D's, and so therefore I can make 2 groups of them, and I would have 1 D left behind. I have 6 X's, I can make 1 group of them, and I would have nothing left behind. So I have an even degree. The D's are not going to need the absolute value because it starts as an odd. I have to check if it's an even and an even on the inside, which means I have to check for the X's. I took out one X, which is an odd number, so the X needs the absolute value symbol. So there you have it for simplifying radicals. There's a couple more practice problems at the bottom of this file. Please go ahead and try those, and then when you are done, you can go ahead and complete the check-in on Microsoft Forms. Thank you.